Welcome back to my garage. Sorry about the voice, I've been hit by the flu. Also sorry if you have sent me a mail and I haven't replied, or a comment or a message. I'm basically overwhelmed and flooded with mails and messages and comments. So I'm really sorry, but I just haven't had the time to reply to everyone yet. Also, to whom it might concern, quit whining about my clothes. Why do you even care? I think I've dressed like this since I was maybe 10 or 9, and I'm not going to change it. I'm comfortable with what I wear, even though I'm 33 now, and I will be comfortable wearing the same stuff when I'm 50 or 60 or 70. Why? Why is that a problem? I don't know. Okay, grab your favorite beverage. I'm out of rum. I'll have to settle for coffee. And buckle up, because this is going to be a long one. But hang in there. There will be a small product review / showcase at the end. Hang in there to after that review too, and I'll show you my plan B, the brute force way. I'm in the process of catching up with two-stroke development the last 2 years almost. It seems that nothing groundbreaking has happened. That's good and bad. Good because I haven't missed out on large stuff. Bad because it would have been cool if I had missed out on something large, groundbreaking. So this is part based on my own experience and ideas, but mostly it's based on other people's research and development. And I have a pretty good idea of what my modifications should achieve. The key here, as with most things, is to not just memorize, but make sure you understand what you read and what other people are telling you. And if you don't, ask questions to make sure you do understand what's going on. And be open, listen, and be open-minded for other people's ideas. And make up your mind if their theories are valid or not. Meditation and pain. The cylinder. First up, Hollenderen commented that by rotating the cylinder 90 degrees on the crankcase, even though I'm going to run a piston without the wrist pin holes and thereby no short circuiting, there would probably be a lot less thrust load on the side of the bore where my gigantic single exhaust port is. So maybe I'm going to run it that way. I think I'll try the normal way first, and if that works okay. If not, 90 degrees twisted. My new cylinder will be based off the Aprilia RSA, which most new cylinders are these days, but with modifications. I'm going to modify the B port transfer duct entrance to go all the way to the C port. I will retain the same volume and entrance to exit ratio, but make it a lot wider where the cylinder meets the case. I will probably make a slightly narrower C port, and that's to make room for a wider B port up top without the traditional hook, but with an even taper from the now wider entrance down at the case. I will use Emot to simulate the engine and find the proper transfer port durations and specific time area. Will probably be around 129, 130 degrees. The time area numbers will need to match the blowdown area. I will run a stagger. The B ports and the C port will open first, and then slightly after the A ports will open. This is due to blowdown area becoming insufficient at higher RPM, and there will be higher pressure in the cylinder than in the crankcase when the transfer ports open. So the first port to open will be the last port to start flowing in the right direction. Doing it this way, with the B and C's opening first and then the A's, causes some backflow in the B and C ports, and this allows the A ports to start flowing first, even though they open after the B and C ports. They sweep fresh mixture over the piston dome, pushing the spent gases in front of it. Then the B and C port joins in, pushes the spent gases in the ducts out, joins with the spent gases pushed by the A ports, and then the fresh mix joins up and collides in the middle and is being pushed up, clinging to the rear wall, up into the combustion chamber. I'm going to make the A ports wider towards the exhaust port and have them angled a bit more towards the rear of the cylinder. This will be made possible by having a narrower and higher exhaust roof. Slightly inside the duct, I will have the exhaust floor opened to transfer port roof height and sloping down from there. I will try to grind down the floor in increments and see what gives best power. The narrow and higher port should lead to less short circuiting and better blowdown flow. Remember, during blowdown, the port is partially blocked by the piston. I'm going to run the 100% of bore width exhaust port, like I've talked about in the previous videos. It's going to be shaped like the traditional 3-port stagger with lower sides than the middle, and the whole port is going to be given a bevel to aid flow. I think I can run a pretty low port, maybe around 190 degrees. We'll see in simulations how high I will need to go to achieve the desired specific time area numbers. The exhaust duct will have a venturi about 60 millimeters from the port window. This venturi will be about 70 to 80% of the total port area. Maybe a bit more because I'm running such a high exhaust duct floor, but something around 70 to 80%, maybe 90. We'll see what kind of velocities the various sizes will create in simulations. This venturi will taper out to 100% of port area at the exhaust flange. This is also meant to keep velocity high enough in the blowdown phase. Everything will be water cooled, the exhaust duct, the outside and the inside of the transfers, and of course up into the head and the case. I'm going to run very high flow. I'm running 20 liters a minute now on the SPX, and that should probably be sufficient, but I might go to 30, even 40 liters a minute. If everything goes to plan, I will be running the brilliant piston Mark Atkinson design with the IFFI Technologies special retained piston ring design. I will be running a toroidal combustion chamber. It will be coated in ceramic coating except for the squish band. That's to aid heat transfer in the squish band, but to retain heat in the combustion chamber. I will be running a smaller plug, a 10mm plug. I don't think you can get anything smaller than 10mm. The case, I will be running a very high crankcase volume, probably around 300 cc, maybe even more. This to have a small mean pressure drop throughout the transfer phase, to have less pumping losses, and a lot of fresh mixture available for the pipe to suck up into the cylinder. The final volume will be based on what gives best resonance and will be found in simulations. I will be running a third bearing outside the variator to reduce bending and hopefully reduce vibrations too. There will be a normal ball bearing on the variator side, because ball bearings can take some axial force, and a roller bearing on the ignition side, or disc side in my case. They can't take any axial force, but this will allow my crank to be floating and reduce friction. I'll be running a longer conrod, been 75mm up until now. The new one should be maybe 85, even 95mm. This because with the longer conrods, your ports can be higher for the same durations and thereby more area. I'll be making a few new pipes. This old one is ugly, but it actually isn't that bad. But I will take advantage of my newly gained blowdown area and make it a bit shorter for higher RPM, and probably tweak the angles a bit. The header and the diffuser especially. I would really like to run the 32mm PWK carb, or even better, Electron. Wish they weren't that expensive. But if vibration doesn't allow, we'll go the pumper carb route. Okay, pretty ambitious stuff. I will need to get a proper prototyping facility up and running. I'll at least need a foundry, a lathe and a mill, and a 3D printer. The usual Chinese companies have been contacting me too, and maybe I'll bite, and the 3D printer should be possible to get for free in exchange for a small review. Although a prototyping facility is the most fun option, a collaborative effort is probably more feasible, and there's a lot of nice people out there, and I'm sure a lot of you are willing to help out with the casting and the milling and the lathe work and stuff like that. Either way, first priority now is learning Fusion and designing that cylinder. Okay, you made it this far, I'll show you something cool. A guy called Sticky sent me this timing tool he's developed, the Buzzwangle ohmmeter. It's an inclinometer that is specially designed to be used as a port and ignition timing tool. Comes with an adapter for various flywheel puller threads, fits a lot of flywheels, not all, but a lot of them, and a simple piston stop for both 14 and 10 millimeter plug holes. Really cool tool, faster than most other methods, can be used to measure port timing too. There's links in the description to the site and to their videos where they show how you use it. Check it out. Plan B, brute force. It's simple really, a conventional two-stroke cylinder and piston, a crank-driven compressor wheel, no pipe, and a secondary smaller piston or drum valve closing off the exhaust duct during the compression stroke. Probably very inefficient, definitely cheating, but possibly more power than with Plan A. Much more power. I'll make a separate video on this Plan B later. Thanks for watching. Let's make this happen. See you next time.